the sum of two numbers is 20, and their product is 96. Find the numbers.
Would the first one be like x plus y equals 20?
Excellent.
I forget what you said for the second.
Very good. And their product is 96.
xy.
Very good. It's a very similar problem with what we just had. Let's solve this time. It doesn't matter. Let's say we are solving for y. So negative x plus 20. So then this y in the second equation will be replaced by what y equals to. And y is the same with negative x plus 20. So I replace y in parentheses, of course, negative x plus 20, and subtract 96 and 0. Why? Because I see it's quadratic. Negative x squared plus 20x minus 96 equals 0. You already know that I will refuse to solve a quadratic equation with a negative leading coefficient. And this time, because the numbers are big, and maybe I don't want to think, I want to use the quadratic formula. No one tells me which method to use at this point. So let's use the quadratic formula. Negative b plus or minus b squared minus 4 times 1 times c over 2a. Where's my calculator? Here it is. Left parenthesis, don't forget left parenthesis for the top. So 20 plus the square root. I also put parentheses under the square root, depending on what type of calculator you have. It may even pop up with it. It's just that my calculator came up with k instead of left parenthesis. Okay, minus 4 times 96, close the parenthesis for the outside and for the numerator, and then divide by 2. And then copy and overwrite. I got 12 and 8. So x equals 12 and x equals 8. For each, I will be able to find the corresponding y value. So negative 12 with minus in front, so negative 12 plus 20 will be 8. And then when I get negative 8 in here, then I will get 12. So there are two possibilities, either 12 comma 8 or 8 comma 12. Check, please. Any questions? Any questions? I jumped to page 600. I don't know if it takes me too far. Oh, awesome. Very good. Thank you. So, systems of inequalities. Last section of chapter 5. Okay. When we solve system of inequalities, they may be linear or nonlinear, both of them. Okay. That's when I am happy to use my colors. You'll see in a moment why. You may remember, I'm sure. Let's start with a simple one in which we don't have a system. It's not a system yet. It's just an inequality. For example, let's look at 22. We are on page 600. And I have y greater than or equal to x squared minus 1. And this is an inequality. It's a nonlinear inequality because it has x squared. And in order to solve an inequality like this, I never said this to you, but this is true here. Solve or graph for an inequality, they mean the same thing. of inequality like this with two variables. We never, ever say that solving is the same with graphing, because it's not the case. When we're asked to solve, we are solving. But in this case, the solutions of this inequality cannot be presented in any way but by graphing the inequality. Okay, so I'll come back to systems. I just want to work on one inequality first, and then we'll go back to systems. Okay, the first step, I set up the inequality. I'm sorry, the equation. And the question is, what is this? I am not changing the inequality into an equation. I just have to set up the equation to graph the equation first so that I can graph the inequality. If I don't graph the equation first, I will not be able to graph the solutions or solve the inequality. This we have a lot of experience with. So in step 2, graph y equals x squared minus 1. We graph this so many times using transformations. It's x squared. And what transformation is this on x squared? X squared minus 1, where do I take it? Left, right, up, down. Anyone remembers? So I know that this is x squared minus 1, down 1. So this was a side calculation or explanation. So now I'm going to graph it. It crosses at -1 and 1 and -1. So I know the graph. The graph is solid curve because or due to the equal symbol. If I don't have the equal symbol here, I will graph. So for greater than, I will graph the function like this. Why? Because points on the curve will not be part of the solution. If I have the equal symbol in the inequality, I will graph it as a solid curve. So this is y equals x squared minus 1. I know everyone sees that this graph, this function, divides the entire area, my sheet of paper, into the inside and the outside. Inside of the graph and outside of the graph. Okay. In step number 3, pick a point to check. Which point will I pick? The easiest on the planet if the graph doesn't pass through it. This is the easiest point on the planet to work with. Why? Because it's 0, 0. I don't have to do anything. So I go back to the inequality. And when I plug in 0 here and 0 here, the left-hand side is 0, greater than or equal to. The right-hand side is -1. If you say that this is true, I will shade in the inside. If you say that this is false, I will shade in the outside. Which one is it? Is 0 greater than or equal to -1? Or is 0 not greater than -1?
It's true.
It is true. So therefore, I will shade in this area, including points on the graph. This is the solution. All this shaded area, including points on the curve, represent solutions to this. You understand? I will not be able to explain to you other than putting in words. The solution is inside the graph of the function. So I have no other way but by graphing it and shading it the correct area. What will happen with a system? We will have more than one, maybe two, maybe three inequalities. We will solve each inequality as we just did, and then intersect, if there is an intersection. So feel free to choose now, anything you'd like from 27 through 62. Oops, through 62 on page 600. Anything you'd like to work on.
37.
37. Let's start with 37. Let's see, where is it? Ah, just -2 less than x less than 5. Okay, this does not have y in it. So it's much easier, but it's a very good example. Much easier than what we just looked at. So I see that these are two inequalities. The first inequality is x greater than or equal to -2. Fine. I don't need all those steps. I only need to establish the equation. There is an equal symbol. I know how to graph this. So it's this line. We always write what they mean and what I graphed, so we don't forget. Okay, now I have the other one, which means x equals 5, is this line, but there's no equal symbol. So this is x equals 5. And now I am told to shade in the region any y. I don't have any restriction on y. It says any y value. There's nothing. If they don't say anything, I can choose any y value I want. So I'm asked to shade in the area or the territory or the region with any y value, couldn't care less, but x is between -2 and 5. All this green area, not points on this line because there is no equal symbol, but yes, points on this line. Yes, and everything else. If you pick any point in this region, you will see its x is between -2 and 5, and y is whatever. Very good pick. Good. Next one. Okay, well, I will pick this time 46. In 46, we have y greater than or equal to x squared minus 4 and x minus y greater than or equal to 2. So y greater than or equal to x squared minus 4, and yes, that's correct. Okay, so first I will take the first inequality, change it into an equation, not changing, but just write this. I already know how to graph this. I will go ahead and just graph it. Both inequality symbols have the equal symbol. Everything will be a solid curve. I know that this is going to cross at -2 and 2, and it's down 4. So 1, 2, 3, 4. 1, 2, 1, 2. So this is the parabola. I do not move on to the second inequality before I shade in the correct answer. Of course, I'm going to pick 0, 0 because the graph does not pass through it. 0, 0. I get 0 greater than or equal to -4. It is a true statement, which means I have to shade in this area, and it represents solutions to y greater than or equal to x squared minus 4. I continue now with the second line this time. I need to find 2 points. When x is 0, y is negative 2. The ordered pair now, 0, negative 2. When y is 0, I covered it, x equals 2. So 2 comma 0, solid line. Okay, 0 comma negative 2 is this point. 2 comma 0 is this point. Solid line, yes. So this is the graph of, and I have to write on it, x minus y equals 2. And forgive me, here I have to write that this, the curve is y equals x squared minus 4. The inside and the graph of the curve represent solutions to this. Okay, at this point, I see that the line divides the territory into 2 parts. One part is above the line, and the other part is below the line. So remember, I will check one or the other. I prefer to check this one because it has the origin, and that's the easiest point to work with. So I'm checking this area. If it's true, I will shade it in. If it's false, I will shade in the opposite. So with 0, 0, 0, 0, I get that 0 is greater than or equal to 2. If you say true, I will have to shade the area that contains the point I picked. If you say false, I have to shade in the opposite area that does not have the point I checked with. So is it true or false?
False.
False. So I cannot choose this area, because if this point gave me a false statement, all the other points will, anywhere. So I have to shade in the opposite. The green territory represents x minus y greater than or equal to 2. Because this is a system like we did before with equations. Whatever I choose as a solution has to verify both. So the first one has a red territory. The second one has a green territory. If they do not overlap, there is no solution for the system. Do they overlap?
Yes.
Good. So this line, this curve, and everything in between. This, solutions to the system.